the next thing that we're going to look at is what if we have a set of terms in which they don't have anything in common between all of them, whether they're 2 terms, 3 terms. Now we're going to actually look at what if we have 4 terms, but there's no common factor between all 4 terms. Well, what's cool about 4 terms is we can kind of split them up into groups of 2. So I can split up the first 2 terms, and then I can also split up the second 2 terms and treat them as kind of small separate problems. So that's what we'll do. So looking at the first 2 terms here, what do they have in common? Well, they have a common factor of, notice, b. So I'm going to pull out the common factor of b. What will that leave you with as your leftovers? Well, it'll be your x plus z. Remember, leftovers get put inside of their own set of parentheses. So that's kind of treating those first 2 terms as their own problem. Now let's look at the second 2 terms and treat them as their own problem. Notice there is a plus in the middle, so I'm going to carry that over. But let's treat those second 2 terms as their own problem as well. Notice, what do they have in common? Well, they both have a 5. So they're both divisible by 5. We can factor out the 5. Then the question is, what's left over from those 2? Well, you get an x plus z. And again, leftovers go inside of their own set of parentheses. Here's what we should be looking at. Now let's look at what we have and kind of zoom out. And you should be saying, wow, that's a weird coincidence. Our 2 leftovers match and look like what we were just doing. Not a coincidence. This is what's going to happen each and every time, assuming you do your problem correctly. If they're not matching up like this, it's because you did something wrong. So this matching piece, this x plus z, is your new GCF. So you're actually going to do a GCF not once, not twice, but 3 times. You did a GCF once with the first pair, a GCF second with the second pair, and now look, another common factor. So now I can pull out the x plus z the exact way it appears, and that's parentheses and all, so I'll pull out the x plus z that matches between the 2. And then now I'm getting a new set of leftovers. What's going to be left over when I pull out an x plus z from both is the b plus 5. And so what's going to be left over in another set of parentheses, remember leftovers go inside of their own set of parentheses, is the b plus 5. And that's my final answer. Now, if I wanted to go backwards and check my answer, how would I make sure that this answer I came up with, matches up with the original problem? Well, remember, how do you multiply something out like this? You would actually, remember from old math classes, FOIL. So I would take my x plus z times my b plus 5, and I'd FOIL it out. So remember, foiling starts by multiplying out, let's see, the x times the b, so bx. And then the x times the 5, so 5x. And then you get the z times the b, which is bz. And then the z times the 5, which would be 5z. And if you look at this, this is what we started out with, just in a different order, and that's all that matters. So this is really awesome. We can even check all of our answers to make sure that they make sense. But how we're actually going to know that we're doing these correctly is because these pieces have to match. If they don't match, it's again because you did something wrong. So if your things are matching, you're most likely doing everything right. So let's start out with looking at a couple examples here. We'll start out with the first one with A, and we're going to start out with 3xy plus 3xz plus 5y plus 5z. And how we know what we're going to do is because we have 4 terms here. Whenever you have 4 terms and you don't have anything in common between all 4, what we're going to do is split them off into groups. We'll pair up the first 2, look for what they have in common, and we'll pair up the second 2 and look for what they have in common. This idea of splitting these up and grouping the first 2 and grouping the second 2 is only used when you have 4 terms, and it's called factoring by grouping. Because why? You're grouping up the first 2 and the second 2. So it's called factoring by grouping. So let's take a look. What do the first 2 have in common? Well, notice that they're both divisible by 3. So I can factor out a 3. Notice they also both have an x. So I can factor out the x. Then the question is, once you pull out a 3 and an x from both, what are you left with as your leftovers? So what will be inside of my set of parentheses? Well, it'll be the y plus z. So when I do the same thing for my second set of pieces here, I should also have the same leftovers. They have to match. So be careful. I'm going to pull down my plus that's in the middle first, and then I'm going to look at my second pair. What do they have in common? The 5y and the 5z, well, they're both divisible by 5, so I can factor out a 5. Then the question is, what are their leftovers going to be? Well, it's going to be a y plus z. And again, leftovers go inside of their own set of parentheses. So right now, if you zoom out and look at what you have, you should know that you did this problem most likely correctly. The reason why? Because you have a matching y plus z term inside of parentheses. So what do we do with our matching y plus z? We pull it out exactly as it appears, parentheses and all. Y plus z gets pulled out of both pieces. Now I'm going to have a new set of leftovers that will go in a new set of parentheses. What's left over when I pull out this y plus z is a 3x plus 5. And that's my final answer, is the y plus z inside of parentheses times the 3x plus 5. Now, I just want to point this out. Has somebody else given me the answer 3x plus 5 times y plus z? That is completely the same idea, because the y plus z is still together, the 3x plus 5 is still together, and you're still multiplying. It's like asking what's the difference between 2 times 5 and 5 times 2. There isn't a difference. So either way, you are fine. And my math lab should not mark either one of them wrong. Continuing along, let's take a look at B. On B, we have 3ma plus 3mb plus 2ab plus 2b squared. Perfect. Again, we have 4 terms. We don't have anything in common between all 4, so this tells us we're going to be doing our grouping again. We group the first 2, and we group the second 2. So let's see, what do the first 2 have in common? Well, they both have a 3, and they both have an m. So I can factor out a 3 and an m from both, and then our leftovers will go inside of a set of parentheses. Well, what's going to be left over is the a plus b. And that'll go inside of our set of parentheses. Now I can carry down my plus that goes in between my 2 groups. Then my second group, what do they have in common? We've got a 2ab and a 2b squared. Well, they're both divisible by 2, and they both have just at least one b, so I can pull out a 2, a factor of 2, and a b. And then my leftovers will go inside of a set of parentheses. Well, if I pull out the 2 and the b from the first one, all I have is an a left, plus pulling out 2, and one of the b's will still leave me with a b in the second set. Now, when we zoom out and look and see what we've got left here, what we'll notice is we did this right, or at least we think we did, because why? What's left over from each matches. The a plus 2b matches. Parentheses and all. So that's our new greatest common factor that we can now pull out, is the matching A plus B, that matches on both of those. Then the question is, what's going to be left over in another set of new parentheses? What's left over is the 3m plus 2b. And just like the last one, if you came up with 3m plus 2b first and then the a plus b second, that's absolutely fine. So if you came up with the 3m plus 2b first and then the a plus b second, that is absolutely fine.